Thanks so much for coming, guys. So I'm not going to use a mic. So if anyone at the back can't hear me, just give me a shout or raise your hand, and so
David,
on. And because we've got another speaker coming, I'm going to be talking more about how we apply these algorithms and so on to boost model engagement and retention more in a production/product setting. And I apologize for people who have been here before because I'm going to give the exact same talk again. So thanks so much. All right, let's make a start. So for me, every single morning when I wake up, I check essentially 3 or 4 sets of emails. Number one is the company metric email, which states what our daily users are for the past 180 days. Want to check to make sure that's growing. Similar to with our day 1, day 7, and day 30 retention, because these are what fundamentally drives the growth of the company. And the second thing I check is a series of the A/B tests that we run on a weekly basis. So each week, the research team have to produce a series of A/B tests, and each one of these represent a unique set of models that we want to test against a production model for which we might consider serving to production. So so there's only going to be one line of math in this entire presentation, which is how we try to understand retention and the retention improvement brought by a new variant model. And we model retention with this pretty pessimistic equation, which is our day N retention is approximately equal to our day 1 retention. This is new user who have signed up, who have decided to send one single message on the app. We define that as the active event. Different companies define it differently. And then we say, day N retention is day 1 retention divided by the decay factor. So N is number of days within that has passed, and beta is a decay parameter, which we fit. So we have 2 groups. One is your control group, which is our production model, the model that's currently serving all our existing traffic. And we want to compare with a variant group. So this is a new set of models that we are planning on testing. And by taking the log of the ratio between the control and the variant and the control group for the nth day, you get a very nice linear equation here. And do people see how this is a linear equation? Raise your hand if you don't see this. Okay, fantastic. So here is the intercept, which is the log of the ratio between your day 1 retention. And then here is a slope, which is the decay parameter, right? So you want your new variant group to decay less, right? So retention is always decaying over time, and you want to decay less in your variant group compared with your control group. And then you can plot this like nice time series, and you can fit your linear trend. You can do your pretty principled math here in terms of actually projecting the standard error or like what the noise is and so on. Let me think. I may have missed something. Sorry. This model is quite pessimistic because obviously it assumes your day infinity retention is 0, but this is actually surprisingly accurate for the first 30, 60 days. I actually lose track at around 180 days. But it's more than enough for you to make a decision to whether to switch a new production model with this kind of prediction. So this is actually a pretty successful test case where you see the majority of our models have an improvement compared with baseline, and that is actually that's actually an OpenAI model actually. Cool. So this is where the problem lies, which is at what time can you tell, right, that you have had a significant improvement over your production model? Because according to this equation, you can have these 2 different modalities. You have one model that's got very high intercept, which means it retains more people on day 1 and day 1 only. And, there's no improvement in the slope, i.e. the rate at which your users decay, your users get bored of your product. Whereas you have another model, which does not retain as many users on day 1. In fact, it's worse than your production model. But for some reason, users decide to come back to it more and more. And here, this is actually a pretty realistic scenario, which we saw around 2 years ago. And model A here typically is defined as an ultra-engaging model, overfitted to the user's immediate preferences. And model B here is more like an assistant model. It's a larger model, it's got more parameters, it behaves more like an AI assistant, People don't really like it from day one, but then on day 2, day 3, they're like, oh, it can do something else, and maybe I can answer my math homework or whatever. So if you look at these 2 cases, you can't really, unless you plot it in this space, basically it's very easy to disregard model B, because you can imagine waiting for a week. You're like, okay, my model B is just worse on retention every single day, right? So you're going to switch your model B off and deploy your model A. But then, with this kind of visualization, maybe by day 5 and so on, you can say, wait a sec, maybe I want to keep this experiment running for a bit longer. And by day 11, you can actually make a concrete decision on switching, on saying model B is actually better than model A in the long run. And thereby this actually poses a challenge, which is, right, I've always found with the AI team, if you have a group of really smart, hardworking, driven people, they have no problem optimizing for a metric. But if you were to say, okay, you do your experiment, let's say someone wants to answer as simply as, for how many epochs should I do my supervised fine-tuning? And the answer is, okay, just deploy several variants and wait for 10 days and you'll get an answer. That's no good. You cannot iterate like that. The only constant to making consistent improvements over time really is by testing out as many things as possible, testing out your hypothesis, collect results as soon as possible, build your understanding and iterate on top. So, this feedback loop is concrete, it's very robust, but it takes too long. So now we understand what the goal is. Then there's the question of what are the techniques. And this chart is like a money chart, essentially. So this is back when OpenAI is actually doing great publications. And I think this is published. I think this is the Instruct or the WebGPT paper or blog post. And essentially, they are showing, right, a very nice scaling law, which is your model performance scales according to parameter size. But this is where I think a lot of modern understanding is still, people seem to forget that yes, performance does improve with parameter size, but by applying these techniques, for example, you can prompt a smaller model, and if you prompt it correctly, it's going to beat the performance of a badly prompted larger model, right? And then if you were to actually fine-tune for your purpose, for your own purpose, you're going to get another performance boost. And here is if you were to apply reinforcement learning with human feedback, and this could mean best of n rejection sampling, direct preference optimization, which the speaker will be talking about later, you get a much larger performance boost. And at the 6B level, right, it's much, much better than a unprompted or even just like fine-tuned 175B model. So just really, yeah. So I like looking at this chart again, because whenever, normally the simplest will be like, oh yeah, let's serve larger model, But then it's really easy to forget there's so much performance gain to be had by going vertically versus horizontally. And this chart is interesting because what's the evaluation metrics here? They choose Likert score. And Likert score literally means you get your 10,000 human beings and you ask them, do you like the response of this output? Rate out of 5. 1 being I don't like it, 5 I like it. So it's interesting how they didn't choose a benchmark like HelloSwag, MMU, and so on, and instead they chose the Likert score. Cool. So going back, so we know what the techniques we should be using. There's plenty papers out there. There's plenty algorithms that's off the shelf. We have plenty data, right? So now it's about applying these algorithms, but what are the problems that naturally arise as you apply these is you're going to say, what benchmarks do I use? What techniques? How much time and energy should I spend on each? Or as simple as how many epochs do I train? Is it true that as my validation loss goes up, my model performance is worse, right? So you're going to naturally have all these kind of questions. And yes, retention does not lie, which is it's probably the most robust thing you can do, right? Which is, does this model actually retain user? Like, have you built a good model? A good model should be a model that user prefer to come back to it again and again, right? But the problem is you need to wait for 15 days because occasionally you get these kind of, these kind of modalities. So what we have found internally is human feedback is always much, much more important than benchmarks. We've been trying a lot of like benchmarks, HelloSwag, MMLU, and so on, AGI eval, but to this day, it's really just getting humans to tell you whether this is good or bad, right, is the most valuable feedback, as long as you have a large amount of human feedback. But luckily, we have a lot of users. So what can we do? So what's our solution to a faster feedback loop? So this is why we actually built Triverse, which is just a submission portal allowing people to submit any models that they want on Hugging Face. And we deploy these models directly to users. Users don't really care about who exactly is serving what model. They don't care whether we're using Mistral, OpenAI fine-tuned, or whatever. They just want the best possible model. And they have a model, they have an active chat session, and we will, once this model, say our internal research team or someone else deploys a model, we push this model directly onto the app backend. And we just randomly show the user 2 responses, one generated by production or like some other competitor's model. And let me just see whether I can dial it back. Okay, never mind. So you see a pop-up here with 2 responses. That's what the user see. And they will select which response you prefer. And we can collect around 5,000 of these kind of battles in under 2 hours, roughly. And with these numbers, you can get a ELO rating. ELO rating by itself doesn't mean much, just like, a chess grandmaster is rated like, over 2,200 or something like that. Here is more like, as you play around with it, we know like 1,300 ELO is insanely high. 1,100 ELO and below, you don't even need to bother A/B testing it. It's going to be a bad model. Let's see. Cool. So now with this tool having built, we can answer things pretty quickly. So this specific tuning curve is the tuning curve of GPT-4o mini. And now you can answer things like, okay, so this, I submit my model, and this is my baseline performance. Okay, I'm going to try generation parameter tuning. Should I do high temperature, low temperature? Should I add a frequency penalty or not, right? And you get this result straight away. You can try different, different generation parameters, and you can pick your best ELO. And essentially, over time, you kind of build an intuition, which is for our purpose, we want high temperature because users come and have very creative conversations. They're not here for code, basically. For code generation, everyone knows you want temperature to be very, very low, close to 0. And cool, so this is just from generation parameter tuning, and then you can do things like advanced prompting, right? Maybe you want to say, make this conversation engaging. But again, as you do these kind of tweaks, how can you tell that is my model actually chatting in a more engaging way, right? It's very easy to fool yourself over this. What are the keywords that you want to be using in your system prompt, right? With this, you can kind of like tweak around different keywords and you can get another ELO performance improvement. And then here is by building a reward model, right? So this is, you can use a reward model, which is just a classifier that sees the payload and sees the model response, or sees multiple model responses and predict which one is the user most likely going to select. And there are different reward model targets you can play around. And so with each generation, you want to generate, 2 times, 4 times. It's more expensive, but then you're essentially, there's a slide with reward model for people who aren't familiar with it, which is you can give the model a payload, like write me a poem in the style of Ernest Hemingway. And you are just exploring the inherent randomness of language model generation sampling, right? Which is, you can imagine, there's a chance the model can refuse. No, I don't know how to do that. There's a chance the model outputs something that's to the style of a different poet, right? What you can do is you can use these human feedbacks to train a classifier which looks at the payload and looks at the responses and predict which one the human is going to prefer. And you can shove this on top of your language model. So you can let your LLM generate all the way up to 16 responses. And then you can see you get a much, much better ELO performance. And then we can do direct preference optimization. You can do what's called iterative DPO, whereby you apply this algorithm once, you deploy it, and collect new, fresh battles and feedback, and then retrain your model and again and again. And here we have two sets of objectives. One is the ELO battle score. The other one, alignment score, essentially is the family friendliness of the model. And for this, you can ask the users as well, right? You can ask the user, do you think this message is appropriate or not? And you can essentially bake this into the data during training, and you can train it multiple times. And you can see by using a balanced strategy, right? Both your ELO and your alignment or family friendliness get better over time. But here is another issue with this kind of optimization, which is what makes a good model, right? At the end of the day, the model has to be liked by people, therefore it has to be used by people. People want to come back to it, and that's your retention, right? That's your day 30 retention. That's your slope of the model. Sorry, that's the slope of your retention graph. And in here, which model do people think is better? I've got model A, model B, model C. What happens when I deploy them into the actual retention test? And it's actually very surprising to see model C performs much worse than model A and model B in real-life retention testing, much, much worse. Model B is only marginally better than model A. And this is a very interesting case of overfitting. But overfitting traditionally is like you're overfitting to your test set, which is held out, right? And it's a stable set of data, so maybe people have snooped the data too much. But in this scenario, all these models have been evaluated live on human preferences. These models have been deployed to a new set of humans, to a new set of 5,000 humans, and they are selecting these responses. So on the ELO space, on the alignment space, it's absolutely, there is no overfitting here. You have successfully optimized for human preference. But what is this human preference? This is the human's immediate preference, which is, I want this response now. I just prefer this response over all responses. But how does that, is there a case where this could be degenerative, right? And in fact, sometimes when you apply DPO once, or like when you use some very aggressive optimization strategy, what you see is, I'll give you guys a more concrete example, which is, imagine you're not optimizing for ELO. You're optimizing for making sure the conversation doesn't end. No end of conversation. What you get typically as the first pass of training for that model will be a model that asks many questions, which kind of makes sense because now you are pushing the conversation longer, but that doesn't constitute as a good model, right? It's a model that people are going to be like, oh man, like it never shuts up. I guess I'll keep on replying. And then on day 2, it's like, there's no way I'm going to be using try again, right? And similarly in this case, right? Maybe the model is a bit too warming, right? Maybe it's like acting more like a sycophant, like you're the best or whatever, and the humans would immediately pick that each time. But then as they look at their whole conversation, there's no nuances, there's no surprises, they don't come back to it. So ELO still to this day suffers from being at a message level evaluation metric. And you can push this message level evaluation up, and it does not necessarily translate into your day 30 retention. And I won't talk for too long because I can spend all day in terms of how do you actually resolve that and what are good sets of metrics. But it's pretty good basically. So going back to the slides, this is where the blending idea is introduced, which is given model A and model B exhibiting these kind of different modalities. Is there a way to create a model called model C, which hopefully has high intercept and also high slope? Turns out all you need to do is randomly route the response between these two models within a conversation. So it's literally a one line in the backend, basically. So you just roll random dice and you say, I'm going to use this backend API versus that backend API. And by doing this, you can actually shift the whole curve up. And when you actually look at the conversation itself, it's not like this model is ignoring this model completely, because from their perspective, right, they said the previous stuff. So what that means is this boring AI assistant is looking back at what it said, and there's some pretty engaging stuff, and maybe this AI assistant adds some more nuances to this conversation. And whereas this model might look back and say, oh, I actually said something pretty reasonable there as my previous response, so I'm going to keep the conversation grounded yet entertaining. So there's no fancy technique going on here is just, and also random is actually pretty hard to beat, actually. So this is an interesting one, which is if you were to route between these two models, and imagine the ground truth is, like the human will for sure select this, right? So this is like rock, paper, scissors game. You can't, this method will guarantee to achieve 50% accuracy. It's a guarantee. So whatever, your router is, you better make sure that it's much, much better than 50%, right? So then even at 70%, your router essentially is still predicting, 50%. Your random strategy is essentially still performing, pretty well. But then we can come into routing, and routing is very, very, very difficult, and we're still trying to make it work currently. And basically, you can take your pool of models, and then you can train a model that kind of look at the payload, and then try to select a model from a pool of models to serve to the user for the next response. And the challenge in routing is similar to what I was saying earlier about overfitting to the message level metrics, which is what is the target metric you're trying to route towards. Because here, let's say you've got 4 models. My model 2 have got 1300 ELO, highest ELO people have ever seen. And I'll tell you, this is a DPO round 3. So we applied iterative DPO 3 times. Okay, we know for a fact this is not a good model because, on retention it's being overfitted. But if your router's target is also human preference, your router will be selecting this model 100% of the time or 90% of the time. And your router will be correct in selecting that, right? So then your router is now essentially just routing everything to model 2, whereas you've got model 3 with say 1240 ELO, so a pretty good model. And let's say someone tells you this has been fine-tuned on only 5 user conversations. Someone has hand-selected, handcrafted 5 conversations that they believe is high quality. And it shows on the ELO space, which is people do prefer it, people like it. It's not a bad model. This model is much more likely to drive retention up because you have not overfitted to direct human preferences. It's just someone who's very unique, who decided to create their own unique conversations. You've trained on it. And as a verification for this model is actually good, now you actually see the ELO performance going up. It's not being directly trained on human, ELO preference. So there's some nuances here. And then obviously you'd much rather the router be routing this. So then, picking the right target for the router to this day is still a challenge. So finally is future work, which is, where we're going next, which is at the end of the day, what really makes a language model unique is the data that is trained on. And for us, a active user on our platform is active for 80 minutes per day on average. And within the app, there are so many signals. So what that means is a user can reroll their message. If they don't like it, they can edit the message. They can quit a conversation. We can log all these time between messages and so on. There's such rich information out there. And they're clearly, 40% of the messages have been rerolled. So they know what they want, essentially. They're trying to guide the conversation somewhere. And at the end, you have this unique experience that some people take screenshots and want to share with their friends and so on. So this is an example of us taking one single bot, which is called X-Men Adventure Games. So this is one single bot created by some other user. And we basically hand-selected, I think like 7 users, single conversation. And these are long conversations. These are like 500 turns in length. And we fine-tune on this single conversation on a single bot. Then we redeploy this model to target specifically to this bot, to all other users that use this bot. And you can see here, essentially 4 out of the 7 models beat our production model in terms of usage, right? Which is, it's surprising and it's not really surprising, right? Which is, the person who really loves this bot really cares about the conversation quality. And they spend ages curating, like trying to refresh, trying to make sure this is the best conversation possible. So then our role really is, abstracting all the complicated stuff away and enable the users to make really, really good AI, right? People on our platform are between the age, I think, 15 to 25. Over 50% of them are actually girls, so they're not typical software engineers. But then, if you were to ask people who are best at rating how good a conversation is, I would say it's the users instead of the engineers.